Hello, and welcome to this Staff Access Masterclass on Single Sign-On and Decentralized Identity Authentication. My name is Rob Walker. I'm the CTO of Sitekit Applications. I'll be joined later in this session by Hamid Mamaniat, who's the System Architect at Blackpool Teaching Hospitals. This Masterclass is number 6 of 7, Single Sign-On and Decentralized Identity Authentication. The session assumes prior knowledge of decentralized identity. If this is not familiar to you, please see the earlier sessions in the series, number 2, An Introduction to Decentralized Identity with INTEROPen from Evening, and also session number 3, Decentralized Identity Protocols and Standards with Chris Eckel. All the masterclasses in this series will be posted to the INTEROPen YouTube channel. Please visit youtube.com and search for the INTEROPen channel. Alternatively, direct links to the videos will be posted on INTEROPen's River collaboration platform. This session is focused on user authentication, which is the process of proving the identity of an individual with a view to allowing them access to computer systems. There are several ways of doing this. Single sign-on, or SSO, is a technology designed to allow users to access several independent systems with a single sign-on. That is, one set of credentials entered once, allowing access to multiple systems. This may occur, for example, as a sign-on at the beginning of the day that allows you to continue to access multiple systems at work throughout the course of the day. Associated with this is reduced sign-on. In reduced sign-on, unlike single sign-on, the user still needs to input some element of their credential as part of each sign-on to each system, but this typically does not include the entire credentials, for example a username and password and perhaps a one-time code, thereby giving the term reduced sign-on. Decentralized identity is a new and emerging technology, one use case for which is allowing for user authentication. This is an alternative means with which to authenticate a user such that they might access work-based computer systems. During the course of the presentation, I'll be giving you a demo of both single sign-on and decentralized identity authentication approaches to allowing users access to systems. We'll then dig into the theory and have a look at what's happening under the hood. I'll go on to explain some of the benefits and drawbacks of each approach, and I'll finish up with a summary and some final thoughts. Please feel free to post any questions that you might have on this topic on the INTEROPen River platform. There will be a particular forum set up called Staff Access, and within that forum there'll be a dedicated topic on single sign-on and decentralized authentication. I'll be happy to tackle any of the questions that you have there. There will also be a live rerun of this presentation and all of the other masterclasses at the INTEROPen Staff Access Hackathon, which has been held on the 21st and 22nd of September 2020. Further to that, at the hackathon there will be a sandpit environment made available to all the hack participants. This sandpit environment will allow you to connect your solutions to both an SSO and a decentralized identity capability so that you can test out both approaches as part of your solutions at the hackathon. Before we move on to the demo, let's talk about 3 models of digital identity that have emerged with the internet. The oldest legacy model of digital identity is the siloed or centralized identity model. Under this model, you have separate credentials and accounts for each system that you use. Each system must authenticate you as part of a sign-on. The standards that underpin this model are SSL and TLS, which are used for secure encrypted transmission of your credentials. Subsequently, and now the de facto widely used model for digital identity on the internet is the Federated identity model. Under this model, you have a set of credentials that are logged with your identity provider. Your identity provider authenticates you and issues you with an identity token. This token can be used to access multiple systems where there is a federation in place between the identity provider and the system that you wish to access. The standards that underpin this model are OpenID Connect and JWT. A new and emerging model is known as Decentralized Identity, otherwise known as Self-Sovereign Identity, which allows individuals to hold their own identities in a digital wallet, form connections with other individuals and peers, and prove their identity without an intermediary being involved, such as an identity provider. The standards that underpin this model are DID, DKMS, DID-Auth, and verifiable credentials. For our first demo, let's look at federated identity with single sign-on. This web application is INTEROPen. INTEROPen is a digital personal child health record. It is also a web application that supports federated identity. No credentials for parents are contained within the INTEROPen application, but rather a federation exists with an OpenID Connect provider. By clicking Login, the user is redirected to a security token service which offers a number of OpenID Connect supporting providers. In this case, I'm going to choose the NHS Login and a National Citizen Identity Service. You can see in the address bar that I've been entirely redirected away to this NHS service. I log into this service using credentials that I've been provided. This service also supports multi-factor authentication. I've been messaged to my mobile phone with a one-time code which I now must enter in order to sign in. This increases security because providing these two factors of authentication elevates the security. I must provide something that I know and also something that I have in the form of my mobile phone. Having authenticated with NHS Login, an identity token is minted and passed back to the INTEROPen application, which in turn verifies the trust of the identity token that was provided by NHS Login, identifying me and signing me into my INTEROPen account. Now that I am signed in with NHS Login, any other relying party applications that support federation with NHS Login, I would be able to log into these applications without having to sign in again, thereby single sign-on. One side note, in the event that I was to log into a second system that supported a federation with NHS Login, during the course of that sign-in, if the NHS Login system were to ask me for any part of my credential, for example, perhaps not my username and password, but re-requested me to enter my one-time code, that would not be pure single sign-on, as I'd been asked to provide something as part of the login journey. In that scenario, this would be known as reduced sign-on, or RSO, whereby I haven't had to provide as many credentials as I would as a full sign-in, but I've still had to provide something as part of the sign-in journey. Let's take a closer look at what happened underneath the hood. In frame 35, the INTEROPen application presents the landing page from which the user selects the sign-in button, causing the users to be redirected away to the intermediary security token service, B2C in this case. B2C presents the user with a number of supported federated identity provider options, one of which is NHS Login. The user selects the NHS Login button and is then redirected away to the NHS Login service, which is an OpenID Connect provider. You can see with the key value pairs in the request here that a number of these match what is specified in the OpenID Connect specification. In the case here of scope, it says that OpenID must be one of the scopes that are requested, and again in the response type you must specify code, and that can be seen up in here, response type code and scope OpenID. The NHS mail provider then authenticates the user on frames 89 and 90 by capturing the username and password, and then sends and captures a one-time code on frames 97 and 98, and then finally it sends a code back to the B2C security token service, and on the server side the B2C security token service then uses this code and exchanges it with the NHS Login token endpoint in order to obtain an ID token. It is this ID token that is proof of the user's identity. Finally, after the B2C instance on line 105 has validated on the server side the identity token issued by NHS login, the security token service then also mints its own identity token, which is then trusted by the eRedbook application on frame 101, frame 110, beg your pardon. If we look at this request, we can see that the ID token is contained within the request that is passed back to the eRedbook application. We can copy this ID token and paste it into a website which will allow us to view the contents of the token. Pasting the body of the ID token, the encoded ID token, into the encoded part of the form then allows you to see the identity attributes that are contained within the ID token on the right hand side. In summary, single sign-on with federated identity increases employee and IT productivity. It does this by reducing the number of support calls for password resets and also improving the ability for IT teams to be able to provision user access. Also, it improves user experience as users can sign in once and gain access to multiple systems, particularly in an enterprise environment. It also improves security with best practice. It does this by enabling more advanced techniques like multi-factor authentication and passwordless policies, and also by centralizing credentials in a single point. Promotes the idea that strong passwords and credentials are centrally held and accessed by the user once, rather than requiring lots and lots of credentials to be remembered across multiple systems, encouraging the user to repeat passwords and choose lower strength passwords. Also, it reduces password fatigue because of the single sign-on nature of the system. The user does not continually have to enter the password over and over each time they want to access a different system. On the other hand, it also introduces a dependency on an intermediary, that being the identity provider. This reduces privacy and also the subject's control over their identity. The identity provider becomes aware when the user wants to log into each system, and also because the identity is held with the identity provider theoretically has the ability to take the identity back away from the individual. Therefore, the identity provider is in control of the individual's identity and not the individual themselves. Let's look at the second part of the demo on Decentralized Identity Authentication. By way of context for this demo, imagine I'm a student studying at Faber College. As part of this demo, I want to download a digital wallet, connect with my college, so that I can be authenticated in the future, and furthermore receive some credentials from my college, like my university degree at the end of my studies. In this demo, I'll be using the Evernym Decentralized Identity platform. The first step is for me to download a digital wallet. I go to the App Store and I download the Connect.me wallet. This downloads to my phone, I accept the terms and conditions, and then I'm ready for the next stage of the process. In the next stage, I visit the university website and I click on the button to connect with my digital wallet. This causes my university website to generate a QR code. I visit back onto the Connect.me app, the digital wallet, and I use the scan feature from the wallet to scan the QR code on the screen. This action forms a private pairwise connection between my university college and my digital wallet. In the final stage of the process, my university is able to issue me with a verifiable credential relating to my university degree using the private pairwise connection that's been formed through the previous stages. An offer for the verifiable credential is sent from the university to my digital wallet. I'm able to open the offer, view the credentials that the university has sent to me, and either accept or reject, which in this case I accept. This causes the verifiable credential to pass over the private pairwise connection, and it's then stored on my mobile phone in my wallet in a secure way. Now that I hold the verifiable credential in my wallet, I can go back and view it, and also in the future I can form connections with other entities, for example employers, and I can respond to requests for proof of my degree by sharing, based on consent, the credential that was originally issued to me by Faber College. This is done in such a way as the verifiable credential can be verified that it was originally issued by Faber College, thereby being a verifiable credential. Let's have a look at what's going on underneath the hood. Introducing the three actors. We have the issuer of the verified credential over on the left here. In our use case, that's the University Faber College. We have the holder, who has a wallet. That was me as a university student in the middle here. We also have a verifier. Wasn't shown in the demonstration that I just gave, but that could be, for example, an employer who wants verification of the university degree. The University Faber College generate a decentralized identifier, or a DID, and associated with this a public-private key pair. The university then register a DID document on the public ledger. This document contains a number of pieces of information, including the DID, the public key within the public-private key pair, and a connection endpoint with other metadata. This DID becomes known as the public DID, as it can be resolved on the public ledger. The private key from the public-private key pair is retained securely by the university within their digital wallet and is not shown on the public ledger. The DID document is therefore held in this part of the architecture. The DID document here with the three primary elements: the DID itself, the public key, the connection endpoint, and other metadata. In the next stage, the university presents a QR code on screen for the student to scan. Embedded within this QR code are a number of elements of metadata, including the public DID of the university. This allows the wallet, with the feature of the QR code scanner, to scan the QR code, gain the public DID, and look up the DID document on the ledger. This initiates a connection protocol which is based on the DIDCOM standard. At the end of this protocol, both the university and the student will have each created a new private DID and associated key pairs. These DIDs are not written to the public ledger, but rather exchanged and held in each other's wallet. The wallets and the exchange include both the DID and the public key that is associated with the DID. This forms the private pairwise connection. Now that the private pairwise connection is formed, the student is able to use a protocol called DIDAuth to prove control of the DID. That is the private DID that is formed as part of the private pairwise connection. They can use this protocol, therefore, to authenticate themselves with the college and gain access to computer systems that the college own in the future. In the final stage, a verifiable credential is issued to the student by the university over the private pairwise connection. This verifiable credential is signed using the private key, which is associated with the public key in the DID that the university has registered on the ledger. This is denoted by number 1 in the diagram here. Furthermore, verifiers can form their own private pairwise connection using the same mechanism and request proof from the student of their verifiable credentials. They can do this by issuing a proof request to the student for one or more of the attributes that are contained within the verifiable credential. Verifiers can then use the public key that's registered on the ledger by the issuer to verify the authenticity and the provenance of the data that was issued by the issuer in the first place. The student can prove that they own their DID via DIDAuth, or that they have possession of a verifiable credential from a trusted source. Both of these mechanisms are alternative ways to authenticate with the university in the future. In summary, with decentralized identity, the subject owns and controls their own identity, not a third-party identity provider. The subject's privacy is improved as a third party is not involved in their sign-in journeys. The private pairwise connections prevent organizations from correlating your identity, your relationships, and patterns of behavior. The public key cryptography that underpins decentralized identity is more secure than usernames and passwords, yet the user experience is much better. However, decentralized identity authentication does not offer single sign-on or even reduced sign-on experience. The user must perform the same authentication action for each sign-on. Decentralized identity is also a revolution in approach, hence it may be a steep learning curve for developers and likely to be a significant change to existing applications and practices. For this third and final part of the demo, let's look at a hybrid authentication model. Let me introduce to the demo Hamid. Hamid, would you like to just introduce yourself and talk about where you work and what you do?
Thanks, Rob. My name is Hamid Mamania, Systems Architect at Blackpool Teaching Hospitals. The system we are integrating with is called Nexus, an in-house developed content management system that hosts a number of locally developed applications such as our clinical portal, ward tracker, and e-discharge system.
We're going to demonstrate a two-part process. In the first part, the employee onboards into the organization. As part of that onboarding process, the HR manager of the organization signs into a portal, connects with the employee using their digital wallet, and issues them with a system access credential. This system access credential is designed to allow the employee to sign into work-based systems across the organization in the future. In the second part of the demo, we'll use the system access credential that's issued to the employee to show how the employee can gain access to the Nexus system. In the first part of the demo, the HR manager signs into their portal. In this case, the HR manager is called Ian Wood. A one-time code is sent to the HR manager's form to add extra security while they're authenticating to the employee portal. The HR manager goes into the connection part of the employment system and enters details for a new employee, in this case Martin McKetney. The HR manager generates a QR code on screen and asks Martin to use his wallet application that's stored on the employee's phone to scan the QR code on the employer's screen, thereby forming a pairwise connection. Martin scans the code and the connection is formed between the employer and the employee. Once the connection is formed, the employer goes into the employee record and uploads a photo for Martin. Once this is complete, the employer can then issue Martin with a credential. The employer issues Martin with a specific credential known as a systems access credential. This is one credential that will allow Martin, once issued, to have access to all work-based systems. The employer clicks on the issue button and the credential is offered over to the employee so that they can hold it on their digital wallet. At the end of the process now, Martin, the employee, is in possession of the system access credential that's issued to him by his employer on his mobile phone. I'm now going to hand over to Hamid, who's going to take you through the second part of the user journey.
Thanks again, Rob. Martin visits the Nexus login page that has a number of options for authentication. The most used option is Active Directory, but we do support smart card login. For this demonstration, Martin will use the staff login button to sign in. At this stage, the QR code is generated and Martin will scan this code and is phoned via the digital wallet. Some background checks are run on the hospital policy system for authorization, and Martin is then signed into the Nexus system where he can navigate to any of the installed applications.
That's great. Thanks, Hamid. From your perspective, what are the benefits of a hybrid approach?
The benefits from my perspective include ease of integration, as we are already experienced with the OpenID Connect protocol. It improves the sign-in process as the user doesn't need to type passwords. All they need to do is scan a QR code on their mobile device. In a decentralized approach, the user owns their own identity. And because the hybrid approach extends the existing access control policy system, the NHS retains control of access control, whereas the user retains control of their identity.
Yes, yeah, that makes a lot of sense. It kind of gives you a good balance there. Wow, that's great. Thanks very much, Hamid, for coming in and helping with the presentation and giving us your perspective. Let's take a look at what's going on underneath the hood. At this stage in the sequence diagram, let's assume that the user has already been issued with their system access credential by their employer. In this case, the user is interacting with a web browser and visits the relying party application. Within our demo, this was the Nexus application. When the user sits at the home screen, they click on the Sign in with Staff Passport button, and as a result of this, the Nexus relying party system issues a standard OpenID Connect authentication request, which redirects the user away to the security token service. The security token service encrypts and stores the request details, including the scope of access, and then displays a QR code on the screen to the user. Embedded within this QR code is a standard SIOP DID request with specifying request URI for the full request object details, which are embedded within the earlier step that's encrypted and stored on the STS. The user uses the wallet installed on their mobile phone to scan the QR code, which reads the request URI and hits the request URI, thereby requesting the full request object which is stored by the STS. Embedded within this request is a request header that denotes whether the client, the wallet, either supports the SIOP DID protocol or the DIDCOM protocol. These are two alternative decentralized identity protocols, and this request header mechanism is the basis of a handshake protocol. In step 7, the STS retrieves and decrypts the requests that are stored in the session back in step 3, and based on the accept header, initiates a protocol depending on whether the request header was either SIOP DID or DIDCOM. Either way, proof of the subject ID contained within the system access credential, which is issued by the employer, is sent back to the STS in step 9 here. The STS validates the proof in step 10, then looks up the identity by the subject ID in step 11, also providing the requested relying party application identifier. The organization access control policy system checks the rights for the identity identified to access the resource, i.e. the Nexus system, and responds with the appropriate claims accordingly in step 13. In step 14, the security token service mints its own ID token containing the claims that it gained from step 13 back from the access control policy system. This response back to the relying party Nexus is the standard OIDC authentication response, which corresponds with the request made back in step 2 up at the top. The relying party application validates the token and as a result allows the user to access the system as normal. Note that the relying party application is abstracted from the new decentralized identity protocols that are contained within between steps 3 and 13, and the relying party application can continue to work as it worked before in a federated mode using the standard OpenID Connect protocol. In summary, to the hybrid authentication model demo, let's look at some benefits and drawbacks of this approach. This approach evolves existing commonly used protocols, OpenID Connect, so reduces the barrier to entry for relying party applications that already support this protocol. The hybrid model provides a better sign-in user experience than passwordless, so this benefit is carried forward. It allows the user to control their own identity. Access control rights or authorization is retained centrally per organization, and it also allows for single sign-on, where the user can sign in once and gain access to multiple systems, which is not the case with a pure decentralized identity authentication. However, some of the privacy benefits of pure decentralized approach are lost, as the intermediary is now involved. However, this may be less relevant in an enterprise environment. Summary and closing thoughts. There are multiple approaches to user authentication, including federated identity and decentralized identity, as we've seen today. There are benefits and drawbacks to each of these approaches. Understanding these will help you to make software design decisions within your own context. I hope you have found this session useful and it has provided some insight into the existing and emerging standards for user authentication. Finally, I hope to see you at the hackathon and perhaps we can work on these things together further.